Okay, hello everyone. Okay, our next topic is capacitance. Now you must have seen this electrical component at many devices, even in your fan, in your AC, in the cooler, or all in all the electronic items is radio. So this is a very electrical component which is used to store electrical energy, and this is known as a capacitor. So what is the meaning of capacitor? How to find its capacitance? So this 2200 micro F, this is known as capacitance. So what is the meaning of this capacitance? This we are going to discuss in about next 4, 5, 6 lectures. So the basic is that you have to revise this slide again and again to learn this topic effectively. So coming to the next slide. Okay, so now we have a conductor here. You can see a spherical conductor is there, and I have to give charge to this conductor. So I'll give the charge step by step. So there's a lot of positive charge here, and I'll charge this conductor. So I'll give charge step by step and see the space around this conductor is getting occupied slowly because we are charging the conductor, and at some point of time all the space on the conductor will get occupied, and then if you try to give more charge, see what will happen. The conductor will not accept the charge because positive will now repel positive. It was repelling previous also, but now the space has been occupied. So every conductor has a specific charge storing capacity that mainly depends on area, because the more the area, so there will be more space to store charge, lesser area, less space to store the charge. So this charge storing capacity is called as capacitance. So in the further lectures, we'll try to derive capacitance of parallel plate capacitor, cylindrical capacitor, spherical capacitor. There are small electrolytic capacitors. So how to calculate capacitance and all these things will come in upcoming slides. Okay, so we'll discuss capacitance of a metallic shell in this lecture. Okay, okay. So now we have covered the topic that capacitance is charge storing capacity. Now let us discuss a few things about potential that we have already covered before. That due to a charge q at distance r, potential is kq by r. So potential is directly proportional to charge. V is directly proportional to q, or vice versa. Q is directly proportional to V, replacing the proportional with a constant, and this constant is called as capacitance. That is Q equal to CV. SI unit of capacitance is farad, and 1 farad is a very large unit, so we use smaller units such as microfarad and millifarad. Micro is 10 raised to power minus 6, milli is 10 raised to power minus 3. The capacitance, the value of capacitance defines how much charge a conductor can store, and it generally depends on area of a capacitor. Now, now first we will derive potential due to a metallic shell and capacitance of that metallic shell. Suppose this is a shell of radius r, and the shell is charged with positive charge q. Now hold the positive charge is on the surface of the metallic shell. There is no charge inside shell, and the radius of shell is r. So at the center of this metallic shell, we have already covered this topic. From center, all the charge is at a distance r. So if you will take a small charge here, it will be at a distance r. If you will take a small charge here, it will be at a distance r. If you will take a small charge here, it will be at a distance r. So potential at center will be kq by r, where k is electrostatic constant, q is charge on the sphere, r is radius of the metallic shell or metallic sphere. Now if you will remember one property, that inside a conductor in electrostatics, potential at all the value is same, at all the point is same. So if if the point is this, then kq by r. Take this point, kq by r. Take even on the surface, kq by r. So the potential on surface of this metallic shell is what? Kq by r. So putting the value of k, that is 1 upon 4 pi epsilon naught, and q is what? Cv. So putting value of q to be Cv and k 1 upon 4 pi epsilon naught, V will get cancelled out with V, and capacitance will be 4 pi epsilon naught R. So if someone asks you what is the capacitance of a single isolated metallic sphere, the answer is 4 pi epsilon naught R. So a single isolated metallic shell or a single isolated metallic sphere, both will have same capacitance. And if you look at the formula, C is directly proportional to R. So it is in line with the logic. See, more the radius, more the area, and more the area, the capacitor, the conductor will store more charge. Okay, now coming to numerical part, see Q directly proportional to V, we have replaced the proportion by equal to and a constant C. This C is capacitance. Always remember, if you replace a proportionality sign with a constant, then that constant will not depend on these parameters. So Q directly proportional to V, proportion replaced by C. Now C will not depend on Q and V. If you will increase V, Q will increase. If you will decrease V, Q will decrease. C will not change. C will depend on other factors that we are going to discuss in other lectures, like for a metallic shell, C depends on radius of that metallic shell. So C is independent of Q and V. C depends on other factors such as the dimension of the conductor, the material of the conductor, the space nearby conductor, what is there in that space, air or any other dielectric medium. So we'll right now confine ourselves to this formula, that is Q is equal to CV. Now there is a numerical that a conductor stores 4 microcoulomb when connected with a battery of 10 volt. Find charge stored by it when potential of battery is increased to 20 volt. So the first condition is that potential is 10 volt and charge is 4 microcoulomb. So what will be the charge when potential is increased to 20 volt? So next potential is 20 volt and we have to find the charge stored. So Q1 equal to CV1, Q2 equal to CV2, but C will be constant because C does not depend on V. So dividing both the equations, C will get cancelled out. Now we have Q1, we have V1, we have V2, so we will get Q2. So based on this video, now you have to submit an online quiz on the basics of capacitance, like the numerical that we have just discussed, the metallic shell one. So you have to remember all these 2-3 formulas, and on the basis of that, you have to submit that online quiz. Okay, many thanks. Bye bye.